Hi guys, I'm Pat Kelly. Okay, let's integrate. They give us this definite integral they want us to evaluate, right? But the first thing you might notice is I have these other three integrals written off to the side, and you should recognize them. They're like the key lessons that you would have learned in this past section. Those are the three integrals that we want to know. You'll probably, hopefully, have those in your head at some point, but I wanted to have them on display because what I'll suggest to you is as you're working through this type of problem, one of the skills that you're really trying to hone is getting the integral that they give you to match one of the patterns here in these formulas, if you want to see them that way. So even with this problem, let's go ahead and jump in. My thought process is which of these three candidates does my given integral most closely resemble? So right off the bat, I think I can rule out the middle guy because in the denominator, notice that it's addition between the two terms. And even more obviously, there's no square root, right? There's no radical, and I have a radical. And I do have the subtraction inside the radical, but both of these guys have subtraction under the radical. So here's my next go-to, is where I look is where the independent variable is. Within that subtraction, my independent variable is second, okay? And that's really the main difference between these two, the first and the third of my options, is in the first case here, the independent variable is second, whereas in the third, the independent variable is first. So that's really suggesting strongly to me that I'm probably going to go with that first guy, okay? Real quick side note too, though, is I'm sure you've picked up on the fact that the third option also has a factor of the independent variable outside of the radical. That's key, yeah, but don't fixate on that. And the reason I'm telling you that is sometimes you'll have an independent variable outside of your radical and sometimes you won't. You'd be surprised how much that doesn't immediately tell me whether I'm going to go with the third guy or the first guy. Sometimes it works, sometimes it doesn't. I'll repeat, what I go to is where the independent variable is in the order of that subtraction, okay? That'll serve you more often than fail you. So go that way. It's my suggestion. So I'm going that way. I'm going to try to get my given integral to match that first formula. And it looks pretty close. The 3 on top is never real significant. That constant factor, you could always even throw it outside in front if you want to. So I'm going to look down in the denominator. In the radicand, that is my a, by the way. Sorry, it's just the way I write a's. So a is just a constant, and u squared is supposed to be my second term there. I have 9x squared. So what I'll do in my work here is start with a u substitution where u equals 3x, and you can see it, I hope, is that u squared would be 9x squared. So immediately I have 1 minus u squared right there. That's perfect, because that'll exactly match this template. I'll finish up my work here now by also addressing the du, 3dx. And that was actually pretty convenient for me because there's the 3 that does appear in my given integral. But again, it wouldn't matter if it did or didn't because it's a constant factor. I could have brought it outside of the integral. Okay, now I'm ready to rewrite this integral. It equals integral of 3dx, that's my du now, square root, the 1 is still 1, 9x squared became u squared, as we discussed, which is a perfect match for this formula. And I don't want to forget, though, that this is a definite integral, so those limits of integration, they're given to me as x values. I've switched everything to u's, so make sure you have your u values. Here's your conversion factor. If x is 0 here, u equals 3 times 0, that's still 0. If x is 1/6 here, u equals 3 times that, so that's going to be a 1/2 here. Okay, now let's integrate. Once you line up the given integral to one of these three formulas, the integration falls apart. That's what's great about this. I immediately know my answer for the integral from this result of the formula. Arc sine of u over a, my u is 3x. Well, I've already converted to use those, so I'll just stick with u, divided by a, which was 1 for me. So I'm actually done, except that this is a definite integral that I'm evaluating from 0 to 1/2. Let's go ahead and evaluate it, and we're going to have our answer. So this equals the arc sine of 1/2, subtract the arc sine of 0. Hopefully you're getting comfortable with these inverse trig functions. You can get these values, especially without a calculator. Arc sine of 1/2. Where does the sine have a value of 1/2? It's pi over 6. Subtract the arc sine of 0. Where does the sine have a value of 0? Well, that's 0. So I would just subtract 0. So I get pi over 6. Okay? I hope that strategy of trying to get your given integral to match one of these three formulas works for you. Go practice it in some of the other problems, okay?